And our first presentation this evening is going to be brought to you by Emily Ann. Emily Ann is a board member in the Buffalo Astronomical Association, an outstanding visual observer. She really knows what she's talking about. And today, Emily Ann is going to present to you about the November 19th lunar eclipse. Take it away, Emily Ann.
Thank you very much, Dennis. Okay, so we're going to talk about the eclipse. Let me share my screen here. We'll get started with that. Okay, so hopefully you can see my screen. So we'll just jump right into it. So if you're watching this, you probably know what an eclipse actually is. You may also know the difference between a lunar and solar eclipse. But what's interesting about this eclipse is, first things first, it takes place on November 19th, taking place between 1 a.m. and just about 5 and 6 a.m. is when it's going to end. But the interesting thing about it is this is a partial eclipse. So I wanted to go over the basics. What makes it a partial eclipse as opposed to what's called a total eclipse, a total lunar eclipse? And eclipses, as we all know, they only happen when the moon and the sun and the earth are all lined up in the right position. And as you can see, we've got our lovely diagram here. Here's the sun and the moon is in the back, and it's casting light on the earth and back behind it. So the eclipse, a lunar eclipse, happens when the moon passes through the shadow cast by the earth. And eclipses actually tend to only happen 2 times a year, what's called eclipse season, which is a cute name for it. I actually did not know about that. And why is this the case? This is because of the intersection of orbital planes. So I'm going to get right into it here. If you think about yourself, if you had like a hula hoop around you, right? Okay. So you're the Earth, and the hula hoop represents the lunar orbit. Okay. So the way the moon is placed when it rotates around the Earth, it doesn't quite sit exactly straight. It kind of, if you tilted that hula hoop in front of you, maybe, so it was kind of off axis, right? So that's kind of the way I believe it's maybe like 5% is off its axis, so it's not exactly straight. It's not a straight plane. And so the Earth also rotates around the sun like this, where it's not exactly a completely flat plane. It's tilted a little bit. So if you had 2 hula hoops, right? Okay, and they were intersecting, that is kind of when that intersection happens, is when you get the chance to have an eclipse. So because of this variation, because of where the moon sits when it goes around the axis, if you look at the second diagram here, you'll see that sometimes the moon, does not pass behind Earth's shadow completely. And sometimes it only passes partially. If we look at this pink moon up here, you'll see that it's passing through this penumbra, this shadow that the Earth is casting, but it's not quite in that umbra section, which is when there's full shadow cast. A penumbra is only partial shadow. So anyway, we'll see in a sec how this actually looks, and during this lunar eclipse and the difference between a partial and a total. But that's kind of the basics, and that's why this is a partial eclipse, is because in this case, on the one on the 19th, we are passing partially into that umbral shadow, but not completely. So when the moon does not fully enter Earth's full umbra, that full shadow, when it doesn't do that, you get the partial eclipse. And another thing that's interesting is the size of the moon based on, when the moon is rotating around the Earth like this, the size of it, when you observe it, the size changes from where you're observing. And that also does affect solar eclipses. That affects what's called an annular solar eclipse versus a total solar eclipse. So that's another phrase you might hear sometimes where you say, what's an annular? Why is that different? It is actually just because the moon, as observed from Earth, is a little bit too small to completely cover the sun. So you do get that ring effect, but you don't cover the full sun there. So it's still amazing, it's an amazing thing to observe here, but it's just interesting that that's because of the size of the moon as observed from Earth. When you're looking at it, it looks smaller, so it doesn't cover the full sun. So it doesn't cover that full disk, but that's kind of our basics here. And I'm gonna go back to this, when I go forward, I might go back just to show again the difference between that partial and total. So the eclipse timeline. So like I said earlier, it starts just around 1 a.m. on November 19th, which is next Friday. And I will actually be popping between this and Stellarium, which is a observatory program, to show you a simulated view of what that'll look like. So at 1 a.m., just about, the moon starts entering Earth's penumbra, which again is this partial shadow, not the full shadow cast by the Earth, but a partial one. So it's going to start getting darker. And then just around 2:15 a.m., the partial eclipse begins, and this is when the moon starts entering our umbra, which again is our full shadow cast. And then at 4:02 a.m., that is the maximum eclipse. So the moon is about 97.9 apparently in that umbra. So that is very, very close to a total eclipse. This is a pretty good, if this is maybe your first eclipse ever, your first lunar eclipse that you want to view, it's a pretty good one. You will not get a period of totality, which is what's called when, you're in that full shadow for a period of time. We're not going to be getting that, unfortunately, but this is the max point, so to speak. And then after that point, the moon is going to leave the umbra and pass back into the penumbra. So at 5:45 or so a.m., the moon partial eclipse is ending. And this is actually where the moon is going to be very low on the horizon, unfortunately. Lunar eclipses can take place any period of time throughout the night. Unfortunately, as it so happens, based on our time and all sorts of factors, it's going to get kind of low. Some lunar eclipses, unfortunately, you can't even fully observe because at that point the moon has already, passed the horizon. It's a little bit too low. And at 7:03 a.m., the eclipse is completely over. The moon is not in any of Earth's shadows anymore, so it's time to go to bed. And I'm actually going to pop over to Stellarium, and let's see, hopefully that showing on the screen, hopefully? Okay, excellent. So here is Stellarium. This is a simulated view of what the moon is going to look like. And this is about 12:30 a.m. So we're going to start here. Like I said, it's going to start at 1 a.m. So we're going to just speed up time a little bit here. Okay, so we're going to see. So it's about 1 a.m. now, and you're going to see it's going to start getting darker, right? Okay, we're going to pause for a moment right about here. So this is almost the maximum eclipse. This is about 3:45 a.m. And as you can see, the moon is reddening. This is a typical, if we were in a total lunar eclipse, it would be red like that. And then we're going to get, let's see, sped up a little bit here. But this is just about at the max point. So, and then we're going to keep going on past that. Okay, and then, but yeah, this is a simulated view. But let me go back to my slideshow here. So yeah, that's the whole eclipse timeline there. So again, it would look a lot different if you were observing this. And some tips, when you're observing, oops, hold on. So some tips if you went out to observe this is that, unlike a solar eclipse, a lunar eclipse, luckily you do not need any crazy safety measures. When you're doing a solar eclipse, you definitely, I know that we do have some upcoming solar eclipses here, but where you would need to have safety measures with your eyes, but we're just looking at the moon here, so nothing to worry about. At this time of year, you definitely will need warm clothes, so that is kind of a safety measure. And what you could do is, if you have the whole night to spend, perhaps, I don't know, in my case, I probably won't be watching this the whole night. I might just go out at the max eclipse, but you can kind of go out a few minutes at a time when you're in each phase. Maybe go out at 1:30, 2:30, 4:02 a.m. Definitely want to catch that maximum eclipse. But you can kind of compare the color and the brightness and take some observations, do that citizen science. And I actually will talk about the color and brightness in just a moment here. But yeah, go out, as the night goes on. And then you can observe a lunar eclipse with your own eyes. You can use a telescope or a pair of binoculars. Any astronomical equipment will work, but even with your bare eyes, you can still see the color change of the moon there, and you can see the effect of the brightness on it, which is pretty cool. I would maybe recommend lunar filters if you do have a telescope, or color filters, because the lunar eclipse is going to take place during the full moon here. It will be pretty bright. So it's not going to hurt your eyes, but sometimes it does help to at least cut down on that brightness so you don't have like one eye that's incredibly blown out and then the other eye is normal. It's kind of annoying. And always, lunar imaging. We have some wonderful eclipse photos, some wonderful solar eclipse photos, but always a fun time to maybe bust out the camera or even take a photo. Maybe if you have just a phone holder, you can take a photo with your cell phone and that'll look great as well. So, and one other thing I wanted to talk about is, again, this is another thing I didn't know about until I started reading about this. It's called hopefully I'm pronouncing this right, the Danjon Scale. And this is a subjective way. It's not it's not really a scientific measurement, but it is a way that if you're observing a total or even a almost total lunar eclipse, you can determine the color and the brightness of the moon on this scale. So as you can see on the left side here, we have, this is a regular moon. And then there are these different numbers. What do the numbers mean? Well, as the values increase, this kind of shows you the different ways a moon can look. And what I want to go into here is, why does the moon look red? Why does it look like this? What is the difference with this variation of color and brightness? Well, that is actually because let me go back here, go back to where. So when the moon is back here, when the moon is in Earth's shadow like this, you would think, why do we even see the moon at all? Because it's in the shadow. It doesn't make sense. Well, the sun is still casting light, obviously, on the Earth, and the light is actually being refracted off of Earth's atmosphere, okay? And when the light goes through, the blue waves of light are actually, they're kind of scattered. They don't go through, but the red does make it through. And this is why, we still see some red light on the moon. And the variance in light actually depends on different properties of Earth's atmosphere. So for example, it's very common to note that if you are viewing a total lunar eclipse from somewhere where like a volcano has recently erupted and you have the dust in the atmosphere, that would actually make the eclipse darker because of the particles of dust in the atmosphere, or maybe water in the atmosphere, water vapor, clouds, and that actually affects the color that you see of the moon. So people in different locations, everyone on the night side of the Earth can see a lunar eclipse when it happens, but if you're in a different location and maybe the atmosphere is a little different where you are, you're actually going to see the moon a little bit differently. So I thought that was really neat. And you might notice here that I wrote total lunar eclipse. Well, in this case, because we're so close to a total lunar eclipse this time on the 19th, you will not, I mean, as we saw maybe when I showed it in Stellarium, hopefully you might have, I think there was something with it, so you may not have gotten to see, unfortunately, but I'll show in a moment what it will look like in image form, but you can still you might still be able to get a number. You're still going to get some variance because we're very, very close to the total lunar eclipse. So I thought that was pretty neat. Again, this is something I didn't know about. So hopefully, if you get a chance to go out next Friday at 4 a.m., see if you can maybe attach a number to what you observe the moon. Again, it's not going to look completely like this. It may not be as vibrant as these higher values here, but it still will be pretty cool. And it's good practice for the lunar eclipses we will be having next year. So I would say get out there and still try to assign a number to it. Try to assign your Danjon number. So I did want to show, these are another simulated image of what the lunar eclipse next week will look like. On the left-hand side, we have maybe a typical view through a telescope. So it's pretty, zoomed in, pretty close. And you can see, hopefully, on the right-hand side here, just a tiny sliver where, again, this is all simulated. This is not what it's actually going to look like. But you can see that it's almost there. It's really, really close. And then on the right-hand side, we have a flipped binocular view. And this is not, it's kind of to scale. It's, I had to cut some off. Obviously in binoculars, it would be much, much smaller. But again, you can see this telescope binoculars or even just your own eyes. It's still going to be pretty cool. And then, yep, I generated this. So this is at 4:02 a.m. So this is the maximum eclipse time. And then I did want to talk about upcoming lunar eclipses. So we actually have 2 total lunar eclipses coming up in 2022. So if you miss this one and it's 4 a.m. and you don't want to go out and it's really cold, I totally understand. Because I myself, I'm definitely going to look at this first one on the left-hand side. Again, this is a simulated view, but this is a total lunar eclipse that will be occurring on May 15th to the 16th. So, in the spring, hopefully it'll be a little bit warmer. And another very cool thing about this eclipse is that the maximum eclipse time is going to take place at 12 midnight. So it's, a nice time in the middle of the night. You view it, you go back to bed. I like that. And then the second eclipse is going to take place almost a year from now on November 7th to the 8th. One unfortunate fact about this one is that the max eclipse time is actually right around like 6 a.m. So that's our max time. Unfortunately, it's going to be very, very low on the horizon here. It's got an altitude of 10, which is very low. So unfortunately, I think this one, you might want to go out and you could see maybe the moon darkening before it kind of takes on that reddish color. You might be able to get that, but unfortunately, depending on where you live and your horizon at home, it might not be a good one. So I would say hold out for the May one if you can. I think that one's going to be really fun. And one other cool thing I found out about these eclipses is they're what's known as a central eclipse. So if we actually go back to I like this diagram a lot. So a central eclipse is where not only is the moon, in this umbra, in this shadow, but it's very close to the center of Earth's shadow. So it's a good looking eclipse, hopefully, right? If we actually can see it, if we don't get clouds and stuff, but it's this orange moon right in the center. It's passing very close to the center, the direct center of that shadow. So that's why it's called a central eclipse. And these are a little bit more rare, actually. So again, both of these eclipses next year are going to be this type of eclipse. And I don't know. I think I've definitely seen a few lunar eclipses, but I think I definitely want to take a look at the one next week, because it's going to be so close to a total eclipse. But I think the May one is going to be very cool. I'm sure we're going to have BAM members talking about it, imaging it, having all sorts of fun with that. So I would say, next week, though, next Friday, definitely get out if you can at 4 a.m. and, take a peek. It's always a good time. I know that they'll probably have streams as well. Usually the time and date site does a stream. So you can always catch that later if you don't miss that. If you can't see it at the time, you can always come back and watch it. But that's about all I got. Keep looking up and get ready for 2024. That's what I'm going to say. Because we're going to get the big famous solar eclipse. It's going to come right through. And this is, solar, not lunar. So this is going to be the ring of fire, the big one, so that keep your eyes peeled for that one. But until then, maybe enjoy some lunar eclipses. And that's all I got for now. So back to you, Dennis.
Outstanding, Emily Ann. Outstanding. That was a tremendous presentation.
Oh, thank you.